Hello children, we are starting mathematics today and the topic is real numbers. Number system starts with natural numbers. They are 1, 2, 3 up to infinity in one direction. If we include 0 also in this set, they become the set of whole numbers. 0, 1, 2, 3 up to infinity in one direction. If we include numbers in opposite direction as well, they become the set of integers minus infinity to plus infinity. Next up in the hierarchy are real numbers. Real numbers are of two types, rational numbers and irrational numbers. Rational numbers are those numbers which can be written in the form p by q, where q is not equal to 0 and p and q are integers. So obviously these all type of numbers can be written in this form. And the numbers which cannot be written in this form are called irrational numbers. There is one more type of number, imaginary numbers, you will study next year. Two very important properties of positive integers are Euclid's division algorithm and the fundamental theorem of arithmetic. In this chapter, we will study the fundamental theorem of arithmetic in detail. However, it is worth taking a quick look at Euclid's division algorithm. Let us see. Any positive integer a can be divided by another positive integer b in such a way that it leaves a remainder r that is smaller than b. Suppose two positive integers are 20 and 3 divides 20. So you get 6 as quotient and 2 as remainder. So as per this theorem, remainder will always be less than the divisor. Now let us see the fundamental theorem of arithmetic. Every composite number can be expressed as a product of powers of primes, and this factorization is unique apart from the order in which the prime factors occur. Let us quickly recall what are prime numbers and what are composite numbers. Prime numbers are those numbers which have exactly two factors, 1 and the number itself. And the composite numbers are those numbers which have more than two factors, 1, number itself, and at least one more factor. Suppose x is composite number. It can be written as product of two or more prime numbers. Now let us do two things. First, let us fix the order of prime factors, means in ascending order from smallest prime factor to largest prime factor. And second thing, if they are repeated, we will combine them. For example, let us take 180 as composite number. So let us factorize 180 this way. So we can write 180 as 2 into 2 into 3 into 3 into 5. Means they are coming in this specific order, ascending order. Means prime factors are coming in ascending order. Smallest prime factor to largest prime factor of 180. And they are repeating. So we will combine 2 into 2 as 2 to power 2, 3 into 3 as 3 to power 2 into 5. Now let us see the definition again. Every composite number can be expressed as a product of powers of prime, and this factorization is unique apart from the order in which the prime factors occur. And we have already fixed as they should appear in ascending order, means the smallest prime factor to largest prime factor. This method is also called as prime factorization method. Let us see this question. Find the LCM and HCF of 6 and 20 by the prime factorization method. If it is not asked to solve by prime factorization method, then you can do your usual way. Means LCM can be found this way, 20, 6 factorize. So LCM will be given by 2 into 2 into 3 into 5, that is 60. 20 can be written as 2 into 2 into 5 and 6 can be written as 2 into 3. So what is common factor? Common factor is 2. So HCF is 2. We have to solve this question by prime factorization method. So first step is to write as multiplication of primes with their powers. So 6 is equal to 2 to power 1 into 3 to power 1 and 20 is equal to 2 to power 2 into 5 to power 1. Now LCM will be given by LCM of these two numbers will be product of greatest power of each prime factor involved in the numbers. So what are the prime factors involved in these two numbers? Will be 2, 3 and 5. Product of greatest power of each prime factor. What is the greatest power of 2? That is 2. What is greatest power of 3? That is 1. What is greatest power of 5? That is 1. So product of greatest power of each prime factor will be 2 to power 2 into 3 to power 1 into 5 to power 1. That is 60. Now, let us talk about HCF. So HCF will be product of the smallest power of each common prime factor in the numbers. So what are the common prime factors? Will be only 2 is the common prime factors in these two numbers. And what is the smallest power? That is 1. So 2 to power 1 means 2 will be the HCF of these two numbers. Third rule, for any two positive integers a and b, HCF of these two numbers multiplied by LCM of these two numbers is equal to multiplication of these two numbers. Notice in this case, when you multiply 6 with 20, you will get 120. And when you multiply their LCM and HCF, you will get 60 into 2, that is 120. So you can say that multiplication of two numbers is equal to multiplication of their HCF and LCM. Second question, express 5005 as a product of its prime factors. So first we will factorize 5005. So we can write it as 5 into 7 into 11 into 13. None of the factors is repeated, so we can write it as 5005 is equal to 5 to power 1 into 7 to power 1 into 11 to power 1 into 13 to power 1. Third question, find the LCM and HCF of 336 and 54 and verify that LCM into HCF is equal to product of these two numbers. First, we will factorize 336 and 54. So 336 can be written as 2 to power 4 into 3 to power 1 into 7 to power 1. And 54 can be written as 2 to power 1 into 3 to power 3. So LCM of 336 and 54 will be given by, first we will see what are the different prime factors involved in these two numbers. So they are 2, 3 and 7. And what is their maximum power? Maximum power of 2 is 4 and that of 3 is 3 and that of 7 is 1. So LCM of 336 and 54 will be 2 to power 4 into 3 to power 3 into 7 to power 1. And that will be 3024. For HCF, we will see that what are the common prime factors in these two numbers. So they are 2 and 3. And what is their minimum power? Minimum power of 2 is 1 and that of 3 is also 1. So HCF of 336 and 54 will be 2 to power 1 into 3 to power 1 and that is 6. To verify LCM into HCF is equal to product of these two numbers, we will multiply LCM and HCF of these two numbers and the result comes out to be 18,144. And when we multiply these two numbers, the result comes out to be same, 18,144. So we can say that LCM into HCF of these two numbers is equal to product of these two numbers. Fourth question, check whether 6 to power n can end with the digit 0 for any natural number n. We know that any number which ends with 0 is divisible by 5. It means 6 to power n should be divisible by 5. It means it must have a factor 5 in it. So let us see. 6 to power n can be written as 2 into 3 whole to power n. That means 2 to power n into 3 to power n. Clearly, it will never have a factor 5. So 6 to power n can never end with digit 0. Fifth question, explain why 7 into 11 into 13 plus 13 is a composite number. We know that a composite number has more than two factors. So let us check. 7 into 11 into 13 plus 13 can be written as take 13 common in both the terms. So it will come out to be 7 into 11 plus 1 in bracket. So it will be 13 into 7 into 11 is 77 plus 1, 78. So it will have at least two more factors apart from 1 and the number itself. So it has minimum 4 factors. That's why it is a composite number. Now let us see this theorem. Let p be a prime number. If p divides a square, then p divides a, where a is a positive integer. Suppose a is 6. If a prime number 3 divides 6 square, then the same prime number should divide 6 as well. That is what the theorem is. Let us see its proof. A can be written as product of prime numbers, where P1, P2, P3 up to Pm are primes may not be distinct. Now squaring both the sides, A square will be P1 into P2 into P3 up to Pm multiplied by itself, means P1 into P2 into P3 up to Pm. So it will be P1 square into P2 square into P3 square up to Pm square. Now as per the fundamental theorem of arithmetics, A square is divided by unique P1, P2, P3 up to Pm, and P is obviously one of them. And we see here in the first line, A is equal to P1 into P2 into P3 up to Pm, means P is one of them. So P divides A. That is what we needed to prove. Sixth question, prove that root 2 is irrational. We will prove that root 2 is irrational by the method of contradiction. In this method, we will assume that root 2 is rational and later prove that our assumption was not right. Let us see how to do that. Assume that root 2 is rational. So root 2 can be written as A by B, where A and B are co-primes, means they don't have any factor common other than 1. Cross multiply, so A is equal to under root 2B. Now square both the sides. So A square is equal to 2B square, or A square upon 2 is equal to B square. Now 2 divides A square, so as per this theorem, 2 should also divide A. This is our first relation. Now if 2 divides A, it can be written as A by 2 is equal to C, or A is equal to 2C. In place of A, write under root 2B. So under root 2B is equal to 2C. Square both the sides. So it is 2B square is equal to 4C square, or B square is equal to 2C square, or B square upon 2 is equal to C square. Now again, as per this theorem, if 2 divides B square, then 2 should divide B as well. Here we are saying 2 divides A as well. That means combining these two, we can say that A and B have a common factor 2. And here we have assumed that A and B are co-primes, means they don't have any factor common other than 1. So our assumption that root 2 is rational is wrong. So root 2 is irrational. Seventh question, show that 5 minus under root 3 is irrational. Again, we will apply the method of contradiction. Assume that 5 minus root 3 is rational. So it can be written as 5 minus root 3 is equal to A by B, where A and B are co-primes. So changing the sides, 5 minus A by B can be written as equal to root 3, or 5B minus A upon B is equal to under root 3. Left hand side is rational. Right hand side we know that is not rational. So our assumption that 5 minus root 3 is rational is wrong. So 5 minus under root 3 is irrational. We have seen this formula, LCM of A and B multiplied by HCF of A and B is equal to A into B, where A and B are positive integers. This formula does not hold true for 3 numbers. LCM of ABC multiplied by HCF of ABC is not equal to A into B into C, where A, B and C are positive integers. Rather, these two formulas hold true. LCM of ABC is equal to ABC into HCF of ABC upon HCF of AB into HCF of BC into HCF of CA. And HCF of ABC is equal to ABC into LCM of ABC upon LCM of AB into LCM of BC into LCM of CA. This is easy to remember, as when LCM is there, HCF will come into picture. When HCF is there, LCM will come into picture. In next video, we will solve competency and critical thinking based questions following the latest CBSE question paper pattern. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.